LaHouse Resource Center is a showcase of solutions for producing high-performance homes for our hot, humid climate and natural hazards, all based on results of building science research. It demonstrates a range of proven ways to gain so many benefits to enjoy every day and to have more control over our lives. Think about it. As we shape our homes, we shape our future.
One of the 4 high-performance building systems demonstrated in the construction of LaHouse is the insulating concrete form, ICF system, used to build the teaching center within the garage building. ICF construction consists of polystyrene foam panels with strong plastic connectors and steel rebar to make foam blocks that are stacked, creating a form for pouring concrete walls. The result is steel-reinforced concrete walls with thick insulating foam. So construction is fast and with practically no material waste. In fact, a class of LSU construction management students built the ICF walls in 2 weekends with training and supervision from the experienced contractor. These ICF walls provide continuous R22 insulating value with uniform expanded polystyrene foam on both sides. The wall system is also inherently airtight. When combined with an air-sealed ceiling or unvented roof, and airtight windows and doors, ICF can produce a highly energy-efficient building. Since ICF walls contain a 6-inch thickness of steel-reinforced concrete with steel rebar embedded in the slab, it is an exceptionally strong and wind-resistant wall system. In fact, ICF can be engineered to create a tornado-safe room that meets FEMA standards. Solid concrete walls are safe from termite damage. However, termites can tunnel through the foam, so the foam is 8 inches above grade to prevent hidden entry, and borate-treated structural wood was used for the roof rafters, decking, and window bucks, so the structural building cannot become food for wood-destroying insects. In part 2 of this video, you will see how the ICF LaHouse Teaching Center was assembled from start to finish and why. LaHouse Insulating Concrete Form Building System from the ground up. The slab foundation was built to protect the building. Long-lasting chemical soil treatment provides termite protection. A strong 6 mil vapor barrier lines both the flat ground and the trenches all the way to the surface grade to prevent wicking of moisture from the ground. And a post-tension system was used to protect the slab from our expansive soil conditions. The slab is 8 inches above grade for easy termite tunnel inspection. During slab formation, rebar was embedded every 4 feet into the slab perimeter before it cured. This served to secure the walls to the foundation. Each pre-manufactured rigid foam wall panel has sturdy, high-density plastic webbing embedded in it. Connectors were snapped in place on site to create the 12-inch thick wall forms specified for LaHouse. The forms were placed along the slab perimeter and stacked layer by layer, with adhesive applied between the layers. Both horizontal and vertical rebar was installed inside the forms for each layer. The foam forms were easily cut to fit the door and window dimensions. The openings were lined with pressure-treated wood bucks for framing to attach the door and window units. After the foam forms were stacked to full height, temporary braces were installed on the interior and corner reinforcements on the exterior to support the forms during the concrete pumping. The bracing kept the walls straight and even and helped to prevent breakthrough. Then, a low water to cement ratio of concrete was gradually pumped into the forms in layers to fully fill the cavities and to prevent blowouts from too much pressure. Before the concrete fully cured, treated wood top plates were installed with anchor bolts, same as is done in a slab foundation. Metal plates tied the top plates to the rim and the joists, and metal twist straps wrap over each roof rafter and tie it to the rim framing. Borate-treated roof rafters and decking panels offer high strength and moisture performance as well as decay and termite resistance. The fortified roof decking is 19 32-inch thick and attached with ring shank nails at 6-inch spacing to resist pullout from uplift. Notice the decking is also marked with a grid to make installation faster and more precise. For a hurricane-fortified roof, the roof decking seams were taped with a roof-tolerant tape to form a secondary water barrier. The synthetic roofing underlayment installed is extremely tear resistant. In fact, before the roofing was installed, this underlayment survived both Hurricanes Katrina and Rita without one tear. All windows and doors are impact-resistant units with break-resistant insulated glass for protection from flying debris and providing high security. The garage door is insulated to R9 and reinforced for high wind design pressure and impact resistance. A typical garage door is normally the most vulnerable opening in a home during a hurricane, and its failure can lead to major structural damage. In addition, a waterproofing coating was applied to the bottom 3 feet of the exterior walls. This enables the building to be dry flood-proofed with watertight flood enclosures installed at the doorways. Dry flood-proofing can qualify for flood insurance in commercial buildings, but not in homes. To top off the building's energy-saving features, R38 stabilized cellulose insulation was installed over a sealed ceiling. A cool color metal roof is installed. The special heat-reflective paint gives the dark brown color the solar heat reflectance of a light color, qualifying for an Energy Star label. Of course, the metal roofing is also very durable, installed for high wind resistance, and is a standing seam, snap lock seam type of roofing. Since it has no exposed fasteners, it needs less maintenance and is less prone to leaks. A few points to consider. Plumbing and electrical channels are a simple process, but penetrations, alterations, and structural attachments involve drilling into concrete. Siding and other attachments need to align with the embedded webbing or go past the thick foam into the concrete. Using this technology to best advantage requires training, experience to get past the learning curve, and specialized equipment. ICF building systems typically cost 5 to 10% more than standard construction, but that investment provides extra high performance in durability and energy efficiency. It is especially well suited to coastal areas and may qualify for more favorable insurance terms and discounts. To pass along some lessons learned. All construction workers need detailed guidelines in how to properly attach things to ICF walls, since there is 2.5 inches of foam to penetrate before reaching concrete or the plastic connectors. With less on-the-fly flexibility, all dimensions, details, components, and methods should be fully determined and specified before beginning. Correcting errors requires a jackhammer. In summary, insulating concrete form construction is an innovative system that offers fast, labor-saving, low-waste, energy-efficient, and exceptionally strong wind and flood-hardy building for the higher investment and a higher performance. You're invited to explore LaHouse inside and out, its cutaways, feature signage, models, publications, library, and the website, and to learn about how you can shape your future with a high-performance home.